student should study the three main tests for symmetries. Symmetry with respect to the y-axis, symmetry with respect to the x-axis, and symmetry with respect to the origin. For symmetry with respect to the y-axis, if xy belongs to the graph, then negative xy also belongs to the graph. Therefore, we are going to replace x by negative x in the function and see if it stays unchanged. Y is equal to 1 over negative x squared plus 5, and negative x squared between parentheses is negative x times negative x, which is x squared plus 5, and the function didn't change. So the function is even, symmetric with respect to the y-axis. X squared minus y squared is equal to 1. We check for symmetry with respect to the y-axis. We're going to replace x by negative x and see if the function stays unchanged. Negative x between parentheses squared minus y squared is equal to 1. And negative x between parentheses squared is the same as x squared. X squared minus y squared is equal to 1. Function didn't change, symmetric about the y-axis. For symmetric about the x-axis, if xy belongs to the graph, then x and negative y also belongs to the graph. We're going to replace y by negative y. It's going to be x cubed plus, between parentheses, negative y squared minus x times negative y squared is equal to 0. So both negative y squared are squared, therefore they're going to be equal to y squared. Y squared minus x times y squared is equal to 0, and the function stays unchanged. Therefore, it's symmetric about the x-axis. We'll do the same thing for problem 4. We're going to replace y by negative y and see if the function will stay unchanged. Remember, if xy belong to the graph and it's symmetric about the x-axis, then x negative y also belong to the graph. Therefore, we're going to replace y by negative y and see if the original equation stays unchanged. I'm going to have x cubed minus negative y squared is equal to 2. And we know that negative y squared between parentheses is equal to y squared. Therefore, our final answer is x cubed minus y squared is equal to 2. Therefore, the function is symmetric about the x-axis. For example 5, we will check first for symmetry with respect to the origin. If xy belongs to the graph and it's symmetric with respect to the origin, then negative x, negative y also belong to the graph. We're going to replace x by negative x and y by negative y and see if the function stays unchanged. Negative y between parentheses to the fifth is equal to negative x to the third. Both exponents are odd. Therefore, negative x to an odd exponent between parentheses will be the same as negative x without parentheses exposed to that odd exponent. Now, as we can see, negative y between parentheses to the fifth will be equal to negative y to the fifth. Similarly, negative x between parentheses to the third is equal to negative x to the third. And when we divide both sides by negative 1, y to the fifth is equal to x to the third. The original equation did not change, therefore the graph is symmetric with respect to the origin. For symmetric about the x-axis, we're going to replace y by negative y. And when we do, we get negative y to the fifth equal to x cubed, which is not equal to the original equation. For symmetric about the y-axis, we're going to replace x by negative x. And when we do, we find out that y to the fifth minus x cubed is not equal to the original equation. To check for symmetry in the x-axis, if xy belongs to the graph, then x negative y also belongs to the graph. Replace y by negative y and see if the equation stays unchanged. So x squared is equal to negative y between parentheses to the third. X squared is equal to negative y without parentheses to the third, which is not equal to the original equation. To check for symmetry about the y-axis, if xy belongs to the graph, negative xy also belongs to the graph. Replace x by negative x. Then we're going to have negative x between parentheses squared is equal to y cubed. And the exponent is even. Negative x squared is equal to x squared. Negative x times negative x is equal to y cubed, which is the original equation. So it's symmetric in the y-axis. Symmetry about the origin, we're going to replace x by negative x and y by negative y. If xy belongs to the graph, negative x, negative y also belong to the graph. So negative x between parentheses squared is equal to negative y between parentheses cubed, which means x squared is equal to negative y cubed, which is different from the original equation.